All right, everyone, we're moving into Unit 2, which is going to tie up a lot of loose ends from Unit 1. For instance, we're going to talk about static in this video. So, object-oriented programming seeks to make complex programs more intuitive by modeling objects in relationships that occur in the real world. In our first unit, this is what we were talking about. OOP, we're talking about why objects exist, why you want them. The whole point of OOP is to kind of make those particularly large projects a little bit more intuitive, which helps with the design process and helps keep you like on track. That being said, defining a method that doesn't want or need an implicit parameter, an object, sometimes makes sense. And that is the whole point of static. A static method can be called without constructing an instance of the class it's defined in. Okay, something of note, the methods that we were working with basically the entire last unit, they're instance methods, right? Our getters and setters. Keep in mind this word instance is synonymous with object. They're object methods, right? You have to have an object in order to use them. However, if a method is static, you don't. Okay, static is a reserved word and a modifier. Here is a list of some modifiers, some that you might be familiar with, like public and private. Protected is also in that mix. I'll talk about later what protected is much later, like next semester. Final, we won't really cover too much. Static's what we're talking about now, and we actually will learn abstract, definitely. So I only talk about modifiers is because whenever we get to our method syntax here, right? Method syntax. We have our modifiers show up front. We're talking about like defining a method. We have our modifiers up front, right? Things like public. As we're learning, static is in there. Then we see the return type for the method, things like void, and then any of your primitive data types. The method name, your parameters. Okay, you know this. Okay, but there's a note here that order of modifiers technically doesn't matter. So you can put all your modifiers up front. Examples of modifiers are these things. And when I say order doesn't matter, well, we've got used to making, methods something along the lines of public static. All right, those are modifiers. All those are up front. Then we get to our return type, int, max, name of the method, blah, 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 blah. What I'm saying is order does not matter. You could say static public, and that works. I don't know of any crazy human beings on the planet that actually do that, but it syntactically works. All your modifiers go up front, and the order actually does not matter. Okay, here is something to note. Static methods don't have an implicit parameter, right? In order to call these methods, you don't need an object. Any values that method needs are going to be explicit parameters. Right? And while any class can define one or more static methods are often found in utility classes. Classes consisting of nothing but static methods. I want you to think for a moment. We actually know at least one, maybe more, utility classes. Okay, and all of this is about to make sense the moment that you realize that the math class is an example of utility class. Okay, here is some math methods, right? Absolute value, max, POW, how we do exponents, and then SQRT. All of these are static. Note in our method signatures here, right? These are select methods coming out of the math class. We see the names, we see the explicit parameters, we see return types. It says down here, there's a note, underline indicates that the method is static. In fact, all of the methods out of the math class are static. Okay, that's what makes it a utility class. All the methods defined in the math class are static. In order to call a static method, such as SQRT, you don't need to make an instance of math. You don't make a math object. We have never made a math object. We have used these methods. We've never made a math object, right? We've made scanner objects. More recently, we started making custom objects. We've never made a math object. Like all static methods, SQRT can be called by referencing the class that it's defined in. Instead of creating an object, you simply call the class that it's defined in, right? When I want to use SQRT, square root, I just say math.sqrt, right? This tells me what class it's defined in, and then the method that I want, and then I'm just using the method. Okay, note in this example, I didn't make a math object. I'm referring to the class. The capital letter here is a big giveaway. This is going to give me back a double, which I'm saving and then printing it off. Math is not an object. It's not an object variable. Math is the class that the static method sqrt is defined in. From a design standpoint, here's where I hope everything clicks. From a design standpoint, these utility classes make sense. They exist for their functionality, not their ability to model real-world objects. Besides, what is a math object? What instance variables would a math object have? That's the important distinction. Okay? With object-oriented programming, we're trying to make objects. Like, we're trying to take data and group them together in something that makes sense. That bit of data, right, that grouping of data has instance variables, right? A dog has a breed and a weight and a fur color. What type of properties does math have, right? This is like an abstract concept. So the reason that all of the methods in the math class are static is because there's no reason to make like a math object. That just doesn't make sense. But I still want those methods. If a class doesn't have instance variables, that class probably shouldn't exist or should be a utility class, such as the math class. The math class gives me one central location where we can put all of these methods that help us do math stuff. But math itself is not an object, right? So simply put, static is the opposite of object orientation. Let's review that. How many implicit parameters does a static method have? Our answer here is 0, right? An implicit parameter is going to be an object that is responsible for calling the method. sqrt is an example of a static method. This is not an implicit parameter. This is just merely the class that this is defined in. Okay, so static methods have no implicit parameters. Instead, the only way to get data into it is through the explicit parameters. Non-static methods are also known as instance methods. I would accept object methods since the word instance is synonymous with object, right? Non-static methods, you do need an implicit parameter. In order to call those dog methods that we made, we had to create a dog. Right? In order to call string methods or scanner methods, you gotta have a string or scanner. You gotta have an implicit parameter. You gotta have an object or an instance of that class. A class that defines static methods but no instance methods is known as a utility class. The math class is a good example of this, and we'll learn a couple others throughout the year. Okay, given this method signature, first of all, I want you to kind of pause and tell me what you know about this. What do you know about this method? Okay, the name of the class is my class. The name of the method is my method. It takes in one explicit parameter, a double. It returns a double. And the fact that it's underlined indicates to me that it is static. Okay? Quick question, how many implicit parameters does it have? The answer is 0 because it is a static method, and static methods don't have implicit parameters. Which of the following can be used to call my method from a separate driver class? Right here I'm trying to create an instance of my class and then call it, here I have an implicit parameter and I'm trying to call this static method. That's not going to work. Choice here, Bravo, I'm referring to the class that my method is defined in. That looks pretty good to me. Charlie is not going to work because we're trying to call it from a separate or driver class. If I was literally in my class, Charlie would actually work, but because we're actually calling it from a separate class, Bravo is our answer here. All right, that's going to be it for static. I'll see you in the next one.